Suppose a curve is defined by the equation x to the 2/3 plus y to the 2/3 equals 4. What are all the points on the curve where the line tangent to the curve is a slope of -1? Well, anytime we talk about a line tangent and the concept of a slope, we have to find a derivative because that's what's going to give us the ability to determine where this curve has a line tangent to the curve that is slope of -1. So first, all that information tells me I have to find dy dx. Now, because x and y, or because y isn't isolated anywhere, and we have something that's not solved explicitly for either x or y, it's best to use implicit differentiation to find the derivative. All right, so to start with implicit differentiation, I have to take the derivative with respect to x of both sides. Now you're probably thinking, how do I know its derivative with respect to x? Well, it's typically speaking, when you have x and y together in a problem, x is the independent variable and y is a dependent variable. So x being independent is the one we're taking the derivative with respect to. Okay, so using implicit differentiation, I take the derivative of both sides. And because it's implicit differentiation, I have to pay a close attention to the letters, because if the letters don't match, I have to tack on a dy dx. So the easy part to this one is this side. The derivative with respect to x of 4 is 0. Over here, I'm just going to separate this. Derivative with respect to x of x to the 2/3 plus a derivative with respect to x of y to the 2/3. I'll take the derivatives of each of those pieces. Since that letter and that letter match, this is just a straightforward derivative, so it's 2/3 x, and I subtract 1 from 2/3, which gives me -1/3. And here, the letters are different. But first, I take the derivative as if they were the same. But since this is a derivative of y with respect to x, that means I have to also include that in the problem. Again, the letters don't match. I have to include dy dx. That's a real simple way of thinking about it. There's a little bit more to why we have the dy dx there. It has to do with the chain rule. You can look at an earlier video to learn about that. But so now that we have the derivative done, our goal is to isolate for the dy dx. Then we have our slope, dy dx. So to isolate that, I have 2/3 y to the -1/3 dy dx is equal to -2/3 x to the -1/3 over on the other side. I just add or subtracted that term from both sides, this guy right here. Now I'm going to continue isolating for dy dx, so I'm going to divide both sides by this guy. So dy dx then is equal to -2/3 x to the -1/3 divided by 2/3 y to the -1/3. Now, because these are the same numbers, those guys cancel. And this simplifies a little bit more to -x to the -1/3 over y to the -1/3. Now, those negative powers that are there, to get rid of them, you just take the reciprocal of these two. So in other words, that negative power sends this guy to the denominator. That negative power sends it to the numerator. So you can rewrite this as -y to the +1/3 divided by x to the +1/3. And again, it's smart to always simplify without negative exponents. It makes your work a lot easier. Now again, if we look back up at the problem, we have our dy dx, which is the slope of a tangent line, and we want that to equal 1. So what we end up having to do is solve the equation -1 equals -y to the 1/3 over x to the 1/3. That's what we have to solve. So if I think back to intermediate algebra, I'm going to multiply both sides by x to the 1/3. So I have -x to the 1/3 equals -y to the 1/3. I can ignore the negatives there. So I have x to the 1/3, not ignore them. I just multiply both sides by -1. Y to the 1/3, so I'll write that down just to keep confusion from happening. And I have to isolate for, well, you can either isolate for x or y here. I guess I should isolate for y. But what I'm going to do then to do that is I raise both sides to a power of 3 to get rid of those powers. So I have x equals y. So now the places on the original curve where my slope is equal to number -1 is wherever on the curve x equals y. So what I have to do is take this guy and sub it into the original equation. And then that's going to give me my points that I want to where the slope of the tangent line is -1 to the curve. So over here I need to sub in. So if I have the original equation, x to the 2/3 plus y to the 2/3 equals 4, and x is equal to y, that means I can say x to the 2/3 plus x to the 2/3 equals 4. Because if x equals y, that means I can substitute in x for y. So I have 2x to the 2/3 equals 4, x to the 2/3 equals 2, dividing both sides by 2. Raise both sides to the power of 3/2. That cancels this out to 1. So I have x to the first equals 2 to the 3/2. And if you do this guy right here, 2 to the 3rd is 8. But this power right here puts the square root over the top of it. Okay, so there x is equal to 2 to the 3/2. But actually here, raising both sides to the power of 3/2 is like taking the square root of both sides. So I really should remember that there has to be a plus or minus here. Always remember that. If you add a radical, which is what I did here, you're going to have that plus or minus there. So 2 x values in my ordered pairs that give me a slope of -1 of the tangent line. I have an x that's going to be -√8, and I have a y, or an x that's going to be +√8. So, however, since x equals y, I'm going to also have that value for y and that value for y as well. And if you want to test whether or not these are actual points on the line, all you have to do is sub them in here, and they should add up to 4.